Mike from Flat Rope Design sent me a box of broken skateboard bits. And I've been for a while now kind of sitting on it and wondering what I should do with it. So I think I'm going to give it a shot and make a ring out of some of this. So I've selected a piece of the skateboard. I've already sanded down the front and the back on my belt sander, and they're really quite flat. It's about 9 millimeters thick or a little bit more. Not quite thick enough for a decent sized Signet ring. So what I'm going to do is I'm going to cut two fronts or the two sides side by side, cut them out and glue them together, and that'll give me my full ring. Now, this is just a proof of concept, and in the future what I hope to do is, if this works, is to actually go ahead and create an already pre-glued up section and then machine it as the front and the back. That way everything will line up perfectly. But for right now, this is the piece that I have. So I'm going to do this on my CNC machine, and I may have lost some viewers right there, but the idea is that I wanted to do it fast and efficiently using very minimal tools on my CNC machine and using a very inexpensive entry-level piece of software to be used from Vectric called VCarve Desktop. It's a very capable piece of software for creating tooling, V-carving, all kinds of other different roughing, finishing passes, and so on. But it doesn't allow you to actually do any 3D modeling. You can import in 3D models, but you can't create your own. So, but I'm going to use a feature of that, and I'm actually going to build my tapered shank using one of its built-in features that it really wasn't intended to be used for. In the hopes that I'll come up with about an 18 millimeter ring at the top of the head, and probably around a 9 at the bottom, and then have room on the top to actually cut a piece of aluminum with a relief on it that I can actually glue to the top of the ring or somehow affix to the top. I haven't figured that out. Again, this is all proof of concept, so if it does work, that's great. But if not, then at least it's going to be a great learning experience for both of us. So the next thing I want to do is show you a bit of video of me actually working in the software, developing the tooling, and then we'll come back and see how it goes. Okay?
We're going to start by opening up a fresh version of VCarve Desktop, and we're going to start a new file. Now the piece of skateboard that I have is about 100 millimeters by 60. It's about 9.2 millimeters thick, and we're going to start out with this very high modeling resolution and a solid color, and we're going to just go with, actually we're going to go ahead and choose that. We're going to click OK. Here we have our job space. So the first thing we're going to do is we're going to start out with the finger hole. Now, like you had seen, I had measured mine using a set of ring sizing. This is a ring sizing ring, I guess, and it worked out that I needed a hole or finger hole to be 19.4 millimeters in diameter. So we're going to go ahead and make this 19.4. Apply and close that down. Now that's the exact size, and I know that what I would like to do when I actually cut this is have it a little bit small so that I can size it up. Maybe I can put an actual sort of comfort fit when I sand the inside of this. So I'm going to go ahead and take that line. I'm going to offset that in about 0.2 millimeters inwards. I'm going to close that down. And this new vector we're going to use, this will be the one that we're actually going to use to cut our hole with. Now we're going to go back to this one here, and we're going to offset that outwards, the thickness of the shank that we would like to have. That's from the finger hole out, and I'm going to go at about 3 millimeters. At first I thought 2.5 was going to be good, but I think 3 millimeters is going to be a good size. That way I've got some extra meat if I have to remove. So let's offset that outwards, and that looks good. Let's close that down. Now what we're going to do is we're going to draw in just a few boxes, and I'm going to use boxes because I find it easier to visualize what I'm doing. So we know that from this line here to there is 3 millimeters. So from there to the top of my ring, the flat spot of my Signet ring, I want it to be about 6 millimeters. Let's just go ahead and draw a box We're going to make it 6 millimeters high, hit apply, close, and then we're going to go ahead and drop that into place where it belongs as a guide. And then what I would like to do is I'd like to make the top of this about as square as I can get. I know it's not going to be too square, but maybe it'll be more rectangular-ish because of the material that I have. So we're going to change this to be the width, undo the X and Y. So that was pressing T on the keyboard while I had that selected. The width of about 18 millimeters. Apply that, close. So this is going to be the top surface of our shank. So we're going to go ahead now and just quickly draw in some vectors and bleed out my construction box. Don't need that anymore. Select this vector, go into node mode by hitting N on the keyboard. Change it to a Bezier curve by pressing B, using my cursor keys just to nudge it over so that I get it pretty straight here. That looks good. That's great. Now I'm going to go ahead and holding down my Control Shift and H key is going to copy that vector across my center line. Grab those two vectors, right click, and we're going to go ahead and join those, move endpoints, and we're going to join it again to close it up with a line. And now there's no point in us having this head part disattached from the shank, so we're going to go ahead and select these two vectors and we're going to go ahead and weld those together. So now we have one shape. So there we go. There is our ring template. Now I decided to actually cut 3 of these in case I make a little mistake when I'm cutting it out of the actual piece of wood, or maybe I might want to try some finishing techniques on the extra one because I've never done this before. I'm not sure actually even how I'm going to finish this. So we're going to go ahead and copy this, and then we're just going to hold down my Control key and drag it across until it's roughly where I think it could be. Around there looks good. Then I'm going to go Control Shift H again. That's going to copy it across my center point, and I have my 3 ring vector sets. Okay, now the next thing we're going to do is this. Right now, because this is VCarve Desktop, we cannot do any modeling, and in the modeling tab we have very limited modeling tools, but the one that we're going to use is right at the very end, which is called Add a Plane Component. So we're actually going to use 3 planes to define the shape of our shank of our ring. So I want it to be thick at the top, so when I glue the 2 sides together it's going to be about 18 millimeters, but I want the bottom to be around 8 millimeters thick. And again, that gives me a little bit of wiggle room to kind of sand things down if I have to make it fit a little better. So what we're going to do is we're going to add in a plane, and the first thing we're going to do is we're going to tilt this plane so that we can get it to the right size, or the right tilt, in order to make the side of my shank. And if you don't understand what I'm doing right now, you will in a minute. So let's go back to the 2D view for a sec. Let's just press F on the keyboard to focus that in. And we're going to use this middle vector to tilt our plane. Okay, so we're going to go ahead and go to select our 0 plane. We're going to go ahead and go into our component properties. We're going to click tilt. Okay, and we're going to set our points. So we're going to set one down here at the bottom of our shank, and then one up here at the top. And what we're going to try to achieve is to have this always stay at 0, but this here be 9.2 less the thickness of my shank I want at the bottom. So, and that would be 4. So this actually needs to be 4.2 at the top, or sorry, 5.2 at the top. And this will all make sense in a second. So we're going to go ahead and tilt that. We're just going to throw in a number, 10 degrees, hit the space bar, go into our 3D view, and we're going to see what happens. So now we have this tilted plane, which is what we want to build the side of our ring, which actually looks pretty good, but now we need to see what the dimensions are, or where we are. So if I hover over the end of this, you look down here in the bottom right corner, you'll see that that's at around 0, which is perfect. And up here is about 4.5, and we need it to be 5.2. So we're going to go ahead and add a little bit to that. Let's make that 12%, and we'll see what we get here. No, we need that to be less than that, so let's make that 11 maybe. That's what we get. This is very much an organic way of doing this. So we have 5.5. Let's make this 10.5. Kind of work our way through this. We're just hovering. So 5.1. Let's actually make it just 5 on the nose. That'll, or as close as we can get to that. So let's just zero that out of there and see what we get. And that's pretty good. That's just a hair under 4. Maybe we'll make it 10.2 degrees. Okay, so that now is just a little, just bang on 5-ish. That's great. And now what we're going to do is we're going to give it a base height. So you'll see now that's the right angle. But now at the bottom, it's at 0. But what we really want to do is we want to make sure that that is at 4. So if we add in 4 to that, look at our 3D view, you'll notice that it comes up. Now it's above my modeling plane. A second ago, if I undo that, if I change this back to 0, you'll see that this actually falls below my modeling plane, which is fine, that doesn't matter. But that's just so you can see what happens when I add the 4 to it. It's actually going to add a bit of material to the back of this and pop it up. Now let's take a look at this and see if we're right. So if we hover over here, we've got 9, which is great. Hover over here, which is 4, which is perfect, exactly what we want. Okay, so now we can start to develop some tooling if we would like. So let's just go ahead and split view this so we can see what's going on. And we're going to pin in our tooling tab, and we're going to go ahead and set our material. Now, the first thing you're going to see if you've machined anything before is that we have this big red arrow here. There's a problem. The total height at the end of this is actually more than the thickness of the material that I have. So if I hover over the top of this up here, you'll see that it's actually at 11.5, which means that it's not going to fit inside my block of material. Now I know that, and I'm okay with that because I'm only going to be machining in this section of my material. But VCarve Desktop needs me to fix that. So how am I going to do that? Well, the first thing we're going to do is we're actually going to cut off the top of this. So we're going to add in another plane, and we're going to go ahead and click that. And we're going to make our start height 9.2, which is the thickness of our material. That's going to bring this, push everything up. But if we go ahead and merge lowest that, it's actually going to crop off the top of our model right there. You'll notice that over here in my tooling, it's happy now. It's happy with that. It's no problem at all. So there we have it. So that's the block that we need. Now, like I said before, I did this once before, and I actually used 3 planes to do this with. I had some of this angle still go below the modeling plane, which meant that I actually had to put an extra plane in there to cut off that. But in this case, it's all looking really good. So that's great. So there we are. Perfect. Okay. So let's just go ahead and say that's okay. We're good with that. So our datum's in the middle, our start point's in the middle. We're going to zero off the top. There's no gap because there's no extra material. And that is all good there for my machine. We can click OK. So let's just go ahead and we're going to start off with we're going to do a quick roughing pass. We're going to grab this vector, the inside vector, this one here, the inside one there, this one here, and this one there. And we're going to go ahead and use my standard end mill that I use for doing roughing. We're going to edit that, and we're going to make sure that we change our step over. When I ran it before, the first time, I ended up having a step over at 10%, which the roughing pass took way longer than what it should have. So this should be around 40%. And click OK. We're going to use a boundary offset. So I need to go outside of my vectors and inside my finger hole by a little bit bigger than the diameter of my tool. And I chose that because I wanted to make sure that I had lots of clearance outside of that. And that worked out fine. And I'm going to leave a machining allowance of 0.2, and we're going to go ahead and calculate that up. And we're going to preview that. And that's exactly what I expected to get. So that's perfect. Great. Now another thing I wanted to do is I didn't want to have to do any tool changes at all on this. So I'm going to use my finishing pass is going to use the same end mill, and my profile cut is going to use the same end mill. So let's close this down. Let's go ahead and add in a finishing pass. We're going to use those same vectors again, same end mill. We're going to edit that. We're going to make sure that it's set to be the step over that I would normally use for any other finishing tool, which is about 10%. Click OK. The boundary offset I'm going to use, oh sorry, and I also had to make sure that in my machining limit was the selected vectors. Make sure you do that. The boundary offset is going to be the same diameter as my tool, which is totally fine. That way I want to creep up to the edges and it should be good. And then, we're going to creep up and go over the edge of these vectors, which is great. And this is slightly less than the roughing pass that I did. And this was actually worked out really well for me because I had made an error and zeroed off my machine by mistake, and I had to find my way back to home again. And so the fact that I had a little extra wiggle room to work with, it really helped if I didn't do my lining up right, and so on. We do a raster machining, and that was great. Let's calculate that. VCarve Pro is going to work its magic. Let's go ahead and preview that toolpath. That's what I hoped I was going to get. That's great. So really I'm going to have these little step lines in here, which I don't mind them being there because they can easily be sanded off. And this is going to be a pretty efficient toolpath, pretty efficient way of doing it. When I ran this toolpath, it ended up running for on my machine for about it was about 8 minutes or something like that. So it worked out really fast and it was great. It was perfect. That looks good. Let's close that down. Now let's go ahead and do our profile pass. Okay, we're going to cut right through the material, starting at the 0, going down all the way through the material. We're going to use the same end mill, which is great. We're going to go outside our lines. That's perfect. We're going to add in some tabs, edit our tabs. And what I'm going to do is I'm going to manually add in my tabs. So I'm just going to put one here, here, at the bottom. I'm going to do 4 on each. On the outside of each ring, and I'm going to do 4 on the inside of each ring. That way I'm sure that everything is going to be held in place when I'm machining and nothing's going to fall out or shoot out. That looks good, so let's close that down. That's great. So there are our tabs, and I chose these tab widths, which worked out well. Let's calculate those. Let's go ahead and preview the visible toolpath, and there we have it. 3 rings that look really good, I think. And that's great.